Today we will be solving this problem called array description. So we know that an array has n integers between 1 and m, and the difference between two adjacent values is at most 1. Given a description of the array where some values may be unknown, our task is to count the number of arrays that match the description. So the first line of our input will contain two integers, n and m. Then the second line will contain n integers up to m, and n here can be as large as 10 to the 5th. And we will need to print the answer modulo a billion and 7, which indicates that the answer will be very large. So let's go to the drawing board and try to work out some examples. So let's try to work out this example here. N is 6 and m is 5. And we have three unknown values here and here and here. So any of these values can be any number between 1 and 5 included. So if we go ahead and list all possible values at each position, we will get the following. So at position 1, the value is already specified, so we can only have 2. At position 2, there is a 0, so we can have any number between 1 and 5. And the same applies for position 3 and 5. Whereas for position 4, the value is already specified, so we can only have a 3 there. And the last position can be only a 2. And as we saw in the statement, the absolute value of the difference between two adjacent positions is at most 1. So now let's go ahead and link all the values that can be part of our array. For example here, since we have a 2 here, we won't be able to have a 4 or 5 because the absolute value of the difference between 2 and 4 is greater than 1. So for this first layer, we will have the following possible combinations. Then for the following layer here, we will have the following combinations. So 1 can have 2 previous values, either 1 or 2. 2 has 3 previous values, either 1, 2 or 3. And the same applies for 3 and 4. And for 5, it has only 2 possible previous values, 4 and 5. Now let's go ahead and do the same thing for layer 3. And now layer 4. And finally the last layer. So any viable answer would be going from this starting position to the last position, taking some of these edges. For example, if we take the following path, we will get 2, 2, 2, 3, 3, and 2. And this is a valid array because the difference between any two adjacent positions is at most 1. So now that we've presented our problem as a graph problem, we can go ahead and find any path from the starting vertex to the last vertex using BFS or DFS. And for each path we count, we will increment the number of paths. And then we will just erase these edges that we used so that we won't use them again. And we will repeat this process until we exhaust all paths. But as we saw, the answer that we're looking for would be larger than 10 to the 9th. And that's why this solution will not be possible. So since this won't work, how can we go about speeding up the process? So what we are looking for is the number of paths from start that I will represent by this vertex, which is position 1 with value 2, to end, which is position 6 with value 2. So basically this is what I need to find. If I am able to count the number of these paths, then I found my answer. So in order to answer this question, we can answer a sub-problem of this problem first. So if I knew the number of paths from start to this node and to this node, then what I am looking for would be just the sum of these two nodes. So this would be equivalent to finding the number of paths from start to 5 2 plus 2 5 3. And similarly again, to find the number of paths from start to 5 2, I would require the number of paths to 4 1 plus 2 4 2 plus 2 4 3. So as you can see here, this starts looking like dynamic programming. Any answer that I am looking for depends on answers that I could have calculated beforehand, because all these positions should have been calculated before moving to position 5. And similarly, this would depend on position 3 1 and 3 2. I wouldn't have 3 0 because it's not valid, and the same thing will happen here again and again. So I could just use a bottom-up approach, starting with the fact that the number of paths from start to start itself is equal to 1. So I would have dp of 1 2 would be equal to 1, and I would initialize all other values with 0. And then if I want to calculate dp of 2 1, for example, which would represent the number of paths from start to this position, this would be equal to dp of 2 minus 1, which is 1, and 1 minus 1 would give me 0, so that's not valid, and 1 minus 0 would give me 1, but as we said, we would initialize that with 0, so this would just give me 0, plus dp of 1 2, and as we saw, this was 1, so there are 1 path from the start to this position, which is actually correct. And we would do the same thing here. We would also get a path from start to this, and as you can see, when we will calculate this, we would calculate dp of 3 1, and this would be dp of 2 1 plus dp of 2 2, and dp of 2 1 was already calculated to 1, and dp of 2 2 was calculated to 1 also, so their sum would be 2, which says that there are 2 paths from the start to this position, and indeed here they are. So that's pretty much it. We will have a 2-dimensional dp in this problem, where the 2 dimensions are the position and the value here. And as for the positions, they can go from 0 to n, and the values from 1 to n. So our complexity here will be O of n times n, because we will visit all these states, times the time required to compute the dp of each state, which is done in O of 1, because we just compute 2 additions in the worst case, namely the 3 values we would have here. And since that's constant, our total complexity will be just O of n times n. So that's pretty much it. Now let's go ahead and see our code. So this is our program. We'll start by reading n and m. Then we will declare a vector of int of size n to store our values. Then we will scan these values. And then I will declare my vector of dp, which is gonna be a vector of vectors of long, as we said the dp will be 2-dimensional, and I'm using longs here to avoid any overflow issues. And I will call my dp the number of arrays, and as we saw, I'm gonna require n vectors to represent the n position, and each vector will be a vector of size n plus 1, because the values can be up to m included, and I will initialize everything with 0. Then for my initial conditions, I can have 2 cases. The first one is, as we saw in our problem, the value at the beginning was fixed, so in that case I will only need to initialize this value here. So this is the first case. If values at 0 is different from 0, then I will just initialize the dp at position 0 of values 0 with 1. Otherwise, if my initial value here was 0 instead. So if this was 0, then my first layer will correspond to this. Then all these values would need to be initialized with 1, and that would be encoded in the following manner. So for all values from 1 to m included, I will need to initialize the number of arrays with 1, which corresponds to the number of paths from start to start. Then I will proceed through all the layers. So for I equals 1 up to, and here again I will have two cases: either my value is known or it isn't known. So if it is unknown, like if values at I is equal to 0, then I will need to update the number of paths for all values from 1 up to m included. And to do that, I will just increment the number of ways to get into ij with the three possible combinations. Either I will take j minus 1, and that's if j is greater than or equal to 1, or I will just take the position j from the previous array, and that's always possible. Or if j plus 1 is less than or equal to m, then I can take j plus 1 from the previous array. Otherwise, if my value is known, I only need to calculate the number of paths for a single value of j. And again, I would have to take care of the three cases. So if values of I minus 1 is greater than or equal to 1, then I can update it with the previous value of values I minus 1. And this is always possible, as we saw. And finally, if values of I plus 1 is less than or equal to m, then I can also update it with values I plus 1. And at the end, I will just calculate the number of paths in the last layer, because maybe here also the last layer is unknown, so I might have 5 numbers here, and all these would consider valid paths. So I would need to calculate the paths from the start to all the possible values in the last layer. So I would look through all the values from 1 to m and sum up the number of paths that reach this position. And at the end, I will just print my total number of arrays, and that would be the final answer. So let's go ahead and submit. So that worked. Thank you for watching. See you in the next video. Bye bye.